Now that we've seen some of the unique properties of right triangles, we're going to take a slight turn and dive into a different area of math that is related to geometry and is one that you may not have seen before, and that is something that we call trigonometry. And trigonometry is just the study of the relationship between the side lengths and angles in triangles. Now there's things we've seen about right triangles that make calculating side lengths much easier. The Pythagorean theorem and its converse, for example, allow us to talk about the lengths of sides in right triangles in ways that we can't about oblique triangles, that is, triangles that are either acute or obtuse. Similarly, there are aspects of right triangles that make trigonometry in right triangles much easier than in a general acute triangle or a general obtuse triangle, and that is why this video is going to introduce you to the tangent ratio in the context of right triangles. So, as we said, to talk about the tangent ratio, we're going to have to start with a right triangle, and we're going to name the sides. In this case, the legs are going to be A and B, and the hypotenuse is C. This is very familiar to us because this is something that we used to name the sides when we were talking about the Pythagorean theorem. And what the tangent ratio does is it takes the ratio of the leg opposite the angle to the leg adjacent to the angle, and that is what we call the tangent. So for angle 1, as you can see, is the ratio of A to B, and that is because for angle 1, A is the opposite leg, and B is the adjacent leg. Notice that at no point do these ratios ever talk about the hypotenuse, C. There are other trig ratios for that, and we're going to see that at a later point in a different video. Similarly, the tangent ratio for angle 2 is slightly different, because rather than having A as an opposite leg here, the leg opposite to, or angle 2, is actually B, and the leg adjacent to angle 2 is actually A. So go ahead, pause the video, copy down this definition of the tangent ratio, or the tangent of an angle. Copy down the diagram where you can see angle 1, angle 2, and the names of the sides, as well as the two fractions that make up the tangent. When we're talking about the tangent, we abbreviate it TAN, or tan. And then we put whatever angle we're using inside the tangent function. This is a function that specifically takes angles. So like I said, pause the video, copy all of this down, come back when you're ready to move on. So sometimes the way that we refer to the tangent ratio is the tangent is opposite over adjacent. And that should make sense because it's the opposite leg over the adjacent leg. In right triangles, one more time, because this is incredibly important, when we're talking about opposite and adjacent, we only mean legs. We are never referring to the hypotenuse ever as far as the tangent ratio is concerned. And that is because there are two legs in the hypotenuse and it is not involved in tangent. So, for example, we could say that the tangent of A, again, opposite over adjacent, the opposite leg to A is 5, the adjacent leg to A is 12. Go ahead, pause the video, and come up with this ratio for the tangent of angle B. Come back when you're ready to see more about tangent calculations and do some practice problems on your own. So for angle B, the leg that is opposite angle B is the leg that has length 12, and the leg that is adjacent to angle B is the one that has length 5. So you may notice some patterns between the tangents of A and B, and that's fine because there is a pattern that's there, but we're going to move on and see a little bit more, and we'll get to see if your observation is correct. So we can also use the calculator to find the tangent of an angle without being given a right triangle. And so there are lots of different calculators that you might have. The next screen is going to talk about how to do this using the computer calculator. If you have another calculator that has buttons that are fundamentally different from what looks like here, which if you have a TI-83, TI-87, 88, 89, the TI Inspire, any of those more complex graphing calculators, you may have buttons that are similar here, or you may not. But if you have a different kind of calculator that you're unsure about, go ahead and let us know, and we can walk you through how to calculate tangents there. So these are two common types of computer calculators, and in general, when you have a calculator that's set up like this, where it's not a graphing calculator where you can create an equation on a screen and set it up how you want and then hit enter, what you're going to do is you're going to make sure that your calculator is in degree mode. And that's incredibly important because there are two ways of talking about angle measure. We have degrees and we have radians. Radians you'll see at a later point in a different algebra class. in this case, we're going to focus on degrees. So you either want to see a DEG in the corner, or you want to see nothing in the corner here. Even though there's an RAD down here, which means radians, because it's just on the button and not actually on the display screen in the calculator, that means we're in degrees. One way you can check to make sure that your calculator is in the correct setting is to take the tangent of 45, because the tangent of a 45-degree angle is 1. If you take tangent of 45 and get anything other than 1, you're probably in radian setting and not in degrees. But in any of these calculators, to take the tangent of an angle, you type the angle in first. So to find the tangent of 42, you would type 4, 2, and then the tangent button, TAN, which is here, and underneath trigonometry here, which brings down a list of trig functions. So if you want to copy this process down, you're welcome to. If it makes sense, you don't need to. That's fine. But what we're going to do is we're going to ask you to pause the video and do a few problems here on your own. We're going to do this first problem up in the upper left together, and then you're going to do the other 3 after pausing the video. So to find the tangent of 30 degrees, we could just put it into the calculator. We're not interested in the tangent of 30, though. We're interested in this value for x. So if we multiply both sides by 25, we get 25 times the tangent of 30 is equal to x. Now, plugging the tangent of 30 degrees into our calculator, what we get is the tangent of 30 is something approximately 0.5774, and rounding to 4 decimal places is a pretty common place to round to. When we're dealing with trig, and then multiplying that by 25 gives us 14.43 as our value for x. The reason why we round to 4 decimal places whenever we're using a decimal approximation for a trig function is because most trig functions will end up being decimals that go on infinitely and never repeat. And 4 decimal places allows us to get a pretty solid amount of precision without overdoing it. So go ahead, pause the video, calculate the missing values in the 2 triangles and the 1 setup that you see. Come back when you are ready to move on. So if we go to the top right corner, we have the tangent of 18 equals x over 10. That means if we multiply the tangent of 18 by 10, we will end up with x. And doing that, taking the tangent of 18, which gives us approximately 0.3249, multiply that by 10, and you get x is equal to 3.249, or approximately 3.25. For the tangent of 77 degrees, here x is in the denominator. So if we multiply by x and divide by tangent of 77, what we'll end up with is x is equal to 12 over the tangent of 77. Now the tangent of 77 degrees is something that's greater than 1. It is 4.3315 or so, through 4.33147, etc., etc., etc. And so when we take 12 divided by that answer, what we end up with is that x is approximately 2.77 units long. Again, if you got something slightly different by rounding, that is okay, but make sure you're in the ballpark. And then here, the tangent of 49 degrees is equal to x over 12. So take 12 times the tangent of 49, and we will end up with our value for x. Tangent of 49 degrees is very close to 1. It's 1.1504 if you're rounding it to 4 decimal places. And then multiplying that by 12 to get that x is going to be approximately 13.80 units. Now we can also use the tangent to find angles and sides in more complex figures. So here we have 42 degrees, and we can see that z is the altitude in this isosceles triangle, and that w is one of the segments. We have a base that's 120, and we can do the same thing here using the properties of isosceles triangles, knowing that the altitude splits the base into two pieces. We're not going to do that here as a part of that video, though you're welcome to do it now as a part of practice. You're going to see that later. Instead, we're going to take a second to find out what do we do if we actually know the ratio but not the angle. In that case, we are going to do something that we call an inverse tangent, which means tangent to the negative first. Now, you'll notice that both in the trigonometry section in the left-hand calculator and on the calculator that we see on the right, neither of those has something that is tangent to the negative first. What this function does is it allows us to put the ratio in and get the angle out. It asks us, or it calculates for us, in the case of the example here, we want to find the angle that has a tangent of 3/4, and that is exactly what the inverse function here does. On the calculator on the right, you will see, and on the calculator on the left, you'll see these little buttons that say second, and that changes the functions that are on the calculator slightly. If you hit the second button there, it will actually put that little -1 over all the functions, which means that we are calculating the inverse version. So in order to find the inverse tangent of 3/4, what we would actually press is 3 divided by 4 to get 0.75, or we could just put 0.75. Then we would press second, and then tan inverse. So you'll get lots of practice with both using the inverse tangent and with using the tangent function, but that's our introduction to trigonometry through the tangent ratio. And the tangent ratio of an acute angle in a right triangle is the ratio of the opposite leg over the adjacent leg.